Hey everyone, welcome back to our today's Python programming series. Today we are going to analyzing machine learning to analyze real-world data. In this video, we will cover logistic regression for classification, Bayesian-Ridge regression for continuous prediction, and principal component analysis (PCA) for dimensionality reduces. At first, let's look at the dataset. This is the dataset from SPSS data. This is real-world data, and you are seeing here the data sample size around 81,000 data. Today we are working with 81,000 data. So let's get started. First, let us start by installing and importing the necessary libraries. These are the necessary libraries. You haven't installed yet. You can install this by that code and then import them. Just run it and wait for a moment. After installing and importing this, we are going to load our dataset using pyreadstat library. So let's make the code. So this is the code. At first, you need a file path. In my PC, there's file path is this. Make sure this file path is correct on according to your PC, and then I use print data.head and print data and print data information. So let's run it, and you're seeing here this is the dataset with data head, and this is the data. Here we are using 81,000 data, and this is the information. Here's 81,066 counts of data for A6, BMI, children, and there isn't any null counts. So then now we'll process our data, will separate features from labels, handle any missing values if necessary, and split the data into training and dataset. So this is for the code. We are selecting features and target variables by x and y. We're using here x is equal to data, A6, BMI, children, smoker, and region, and we're using y as new charges, and you're seeing here new charges. So, and then we're splitting our data into training and test sets by x train, x test, y train, y test is equal to x train test split x y test size 0, 3, random state 42. So let's run it, and then we need another code to start our logistic regression model. So this is the code for logistic regression model. Logistic regression is a classification technique we will use to predict classes based on the features in our dataset. Since AUC is only suitable for binary classification, we will use accuracy and classification report here. AUC means accuracy and classification reports. So let's run it and wait for a moment. And you are seeing here there is a logistic accuracy is equal to 0.99. That means it tends to 1, and classification report is precise 1. We call 1 0.98, 1 1. F1 score and support and accuracy, etc. Then we'll explore BayesianRidge for continuous data. Since AUC is intended for classification, we will use mean square error MSE to evaluate this model. So this is the following code: BayesianRegression, BayesianRidge, and BayesianRegression fit x train, y train, and just run it. It will print the results. BayesianRidge mean square error is equal to 0.3838. So next we are going through principal component analysis. Principal component analysis (PCA) used for dimensionality reduces. This is a technique to reduce the number of dimensions of our dataset while retain the model information. This can help visualize complex data. So this is the following code. We're using a principal component for reduce two components, and here principal component is equal to 2, as we are reducing to two components, and its principal component analysis is equal to fit transformation x. So, and this is the code of the plot of principal component analysis. Just run it and wait for a moment, and then you are seeing here the principal component analysis. First two components results. So now we are going through post hoc analysis with summary of findings. So after building and evaluating our models, we need to summarize the insight we gathered, and for that we need post hoc analysis. So for this is the following code. Here we're using the logistic regression interpreting coefficient, BayesianRidge regression for interpreting coefficient, and principal component analysis for interpreting variance, explained variance ratio, and just run it. And you are seeing here there is logistic regression coefficient for age, sex, BMI, children, smoker, region, and BayesianRidge regression for that, and PCA ratio is for principal component 186.84 and for the principal component 2 12.40. So here logistic regression provides us with an accuracy score and classification report, and then BayesianRidge regression coefficient predict continuous values with an MSE, and then PCA use our data to two principal components in visualization and revealing possible clustering. So thanks for today. Today we explored logistic regression, BayesianRidge regression, and PCA. This technique offers diverse insights and approaches for handling real-world data. Be sure to explore more machine learning technique as you advance. That's for today. So it's time to say goodbye. So bye-bye.